In Chapter 10, we're talking about area, and we're going to start with the area of a parallelogram, and from that we'll get the area of a triangle. So the first thing we'll notice, the definition of an area of a rectangle will be just simply base times height. Remember that area is measured by looking at the number of squares that we can divide something into, counting those squares. So we always want to write our units as units squared. The area of a parallelogram is also going to be base times height, which is the same as a rectangle. And the reason for that is that if we take any parallelogram and we make the altitude here, this right angle, if I would cut that off and move that triangle over to the other side, then you're going to end up with a rectangle. So a parallelogram actually has the same area as long as we're taking the height as being the altitude of this. Do not use the side here as your height for your parallelogram. So we need to think about the base of the parallelogram is really just any side. I could take this red side here, and the altitude would be the segment that is perpendicular to that. Now in this one over here, they're taking the base as this side over here, so to get the altitude, we would need to be perpendicular to that, which could be going like this. They could also extend the side and make the altitude go out here. Notice that in each of these, that altitude or that height would be the same wherever you take that value. It just needs to be perpendicular to the sides. So to find the area of these parallelograms, we just use our formula. Area is equal to base times height. Our base of this one, we don't want to use the 4.5 because our right angle's here. We'll use the 5 times 4, and we get 20. We need to use the correct units because units were given, and so area is measured in inches squared. In the next one, we look where our base is. Now this one is going outside over here, our right angle's here, so the 2 would be our base because 3.5 is perpendicular to that. So our area will be 2 times 3.5, or 7 centimeters squared. In this next example, we have a couple bases in height. We're asked to find DE, which is right here. We need to find DE. So if I'm looking for DE, I would think about my area formula. Area is equal to base times height. DE goes with 9.4. So 9.4 times DE. The problem is I don't know what my area is, so I can't solve this as it is right now. What I'm going to do is I'm going to look at the other side that I have here. Notice that this perpendicular right here would tell me that this would be my height that would match with 13 as a base. So I could also think of my area as 13 times 9, which gives me 117 inches squared. The area of the parallelogram then would be the same no matter which size you take it with. So this area here would also be 117. And that will still be equal to 9.4 times DE. So if I want to find DE, I will just divide both sides by 9.4. And I'll find that my DE is about 12.4 inches to the nearest tenth. Notice this is a length here, so we're using inches and not inches squared. So be careful what you're measuring. Don't just throw inches squared on here now. We're looking at a length here, so it's measured in inches. For the triangle, we want to think of it as, well, it's 1/2 base times height, and we can prove that because if we take any triangle, and if we just copy that, make a congruent triangle, let's work with any triangle, we take that congruent triangle and then spin it around like this, and line up any one of the sides, then we should notice that since these are congruent triangles, this angle and this angle would be congruent, which means we have parallel sides here. This angle here and this angle over here would also be congruent, so we would have parallel sides here as well. So we end up with a parallelogram. So any triangle is going to be half of a parallelogram. And so our area will just be 1/2 base times height. In this example, we have a composite figure, which means we're putting two shapes together. So when we want to find the area, we want to think about just adding the areas together. So the area of the square plus the area of the triangle. So first, the area of the square would be the same as a rectangle, base times height. So all the sides are 6, so it'll just be 6 times 6, or 36 inches squared. For the triangle, we use our formula 1/2 base times height. Our base would be the 6, and then our height, since we have a right angle, is the 8. And so the area of the triangle will be 24. So for the area of the whole thing, we'll just add the 36 and the 24 to get 60. We think about our units, it's area, so inches squared.